So as we look at these bottom six, it is using our brain and our knowledge of trig functions to try to help us out. And so they are kind of strange, but don't let them be too strange. Is there one in particular you want me to work through? 87. Okay, so if I look at 87, a couple things are going on there. Okay, the first thing we notice is we've got sine over cosine. Okay, remember we talked about this yesterday, but this is something we'll do quite a bit in the future as well. Sine over cosine is the same thing as tangent. Okay, now I can only do that if these two angles are the same, and they don't look the same, but they are. Okay, so sine of negative 20 degrees, using our even odd identities, sine of negative 20 is the same thing as sine of 20 with the negative sign pulled out in front. Sine of 380. Well, 380, that's weird. But remember, if it's too big, I can subtract out 360. And if I do that, I am also left with cosine of 20. So now I have sine of 20 over cosine of 20. Oh, that is tangent of 20 with that negative sign we brought out in front. All right, so we simplified that. Then we've got tangent of 200. Okay, the key to that one is knowing that on the unit circle, the tangent of this thing is going to be the exact same tangent of the one 180 degrees across from it. So those two values would be the same. This value right here is going to be the same as that because it's y over x. And so tangent of 200 would be somewhere like right in here. And it's 180 degrees different than tangent of 20. So what that means is both of those tangent values would be the same, because the first and the third quadrants are going to have the same one. So instead of tangent of 200, I'd say, oh yeah, that's the same thing as tangent of 20. And if I take negative tangent of 20 plus positive tangent of 20, those two things are opposites, which is going to get me 0. Tangent 220, this part? Okay. So think of a unit circle. I'm just going to pull up a unit circle up here. Yeah, that one. So if I pulled up any unit circle and I look at it, pick any ordered pair. Pick me an angle. What angle do you want? 30 degrees. If I pick 30 degrees right here and I did tangent, tangent would be 1 over radical 3. Okay? What angle is exactly 180 degrees away from 30? 210. So 210, if I did tangent here, it would be y over x. So it would be negative 1 over negative radical 3. They're both negative, but that doesn't really matter. It's really the same angle. So this right here and this right here are the same. Tangent repeats every 180 degrees. So if I pick any angle, so in that case I was doing 20, well, at 200, it's going to be the same value. And so if I ask for tangent of 200, it's really the same value as tangent of 20. Okay? Where sine and cosine repeat every 360 degrees, tangent repeats, cotangent repeats every 180. And that's challenging. What else? What other of these down below do you want me to go through? 85. So on 85, I've got sine and cosecant. Okay, the first thing, I don't like negative sine, or I don't like a negative angle in there. So I rewrote this thing, pulled the negative out in front. So it's just sine of pi over 12. Okay, cosecant, 25 pi over 12. Well, I don't like 25 over 12. That's bigger than one circle. So I thought, how many times does 12 go into 25? It goes in 2 times. And then I would have 1/12 left over. Well, going around 2 pi really just takes me back to the start. So that doesn't even matter. It's just pi over 12. So then I have sine of pi over 12, cosecant of pi over 12. Those two things are reciprocal. Sine means 1, or cosecant means 1 over sine. So this right here, cosecant of pi over 12, is the same thing as 1 over sine of pi over 12. And if I'm multiplying these two together, this and this are going to cancel, leaving me with just negative 1. Other ones? Keenan? Yep. Yes and no. They don't always have to be that nice, but if they're going to be simplified and they expect you to do them without a calculator, then yeah, they're going to be simple numbers like 1, 0, negative 1. Because otherwise, we would need a calculator to do anything much more substantial than that. The whole idea here is us to use our brains and some trig identities to solve them, and we don't know sine of 400 or sine of 40 or any of that stuff. Other ones? Any of the other ones? Yes, sir? 77. So we're going to do one very similar to that here. But remember, we talked about this yesterday. Sine squared. Okay. Remember, we did Pythagorean identities. One of our Pythagorean identities, y squared plus x squared equals r squared. Well, sine is y squared. Cosine is x squared. And if I'm on the unit circle, then my radius is 1. And so sine squared of any angle plus cosine squared of that same angle is going to get you 1 due to our Pythagorean identities. And we're going to do that again here in a second in bell work. That makes a little more sense. But that's just a Pythagorean identity. That's always going to be true. Anything else there? All right, let's keep doing that, but let's go to bell work. I know that's the tricky part. We'll figure it out here right now. So here we go. Sine of 20. We're trying to find the exact value. That means we're not using our calculator. We're using the unit circle. Well, 23 degrees is not on the unit circle, so it doesn't really help me at all. But we'll have to do it some other way. Sine of 23. Ooh, cosecant of negative 23. What could I do with this negative sign? Pull it in front. And it's cosecant of 23. So cosecant of 23 is the same thing as 1 over sine of 23. So what's going to happen when I take sine of 23 times negative 1 over sine of 23? Get you negative 1 because that and that cancel. They're reciprocals. It's negative 1. And then a plus sign. So plus 2 times cotangent of negative pi over 4. You can just do that. You can know where cotangent or negative pi over 4 lands. It would be in the second quadrant right there. I'm doing cotangent. Or I could use my properties or my even odd identities. What do we do with cotangent with a negative angle? We can pull it out in front. That was one of our identities. And then I'm doing cotangent of pi over 4. So hold up your hand. Cotangent of pi over 4. That's which one? Top, middle, or bottom? Middle. Cotangent of pi over 4 is in the middle. And if you hold that guy down, it's radical 2 over radical 2. What is cotangent going to be? It is 1. Times secant of negative pi over 3. Well, secant, that one goes with cosine. It's a negative cosine angle. So what do I do with that negative if I'm doing the secant or the cosine of it? We don't bring it out in front. It just doesn't matter. That negative doesn't matter because remember, pi over 3 and negative pi over 3, for both of them, the x values are the same. So I don't really care about that negative sign. Pi over 3, so pi over 3, that is, boom, it's that guy right there. The ordered pair is 1/2 comma radical 3 over 2. If I'm doing secant, which one of those two things do I want? The 1/2. I'm doing secant, so what do I do with that 1/2? Yeah, 1 divided by 1/2, you flip it, it's 2. So that is negative 1 minus 4. It gets me negative 5. Everybody kind of okay with what we did there? Let's do the last one. Secant squared of 75 degrees minus tangent squared of 75 degrees. And we're going to do this a lot more later on. But for right now, anytime you see trig functions squared, you should start thinking Pythagorean identities. Okay? And so in other words, I'm going to write down Pythagorean theorem. But it's not sine and cosine. Sine and cosine is the easy one. This one's not sine and cosine. It's secant and tangent. Well, what do I need to divide everything in this problem by to make it become secant? X squared. Because secant is r over x. And so if I divide everything by x squared, oh, look, I've got r squared over x squared. That is secant squared. But I got to divide everything by x squared. What is x squared over x squared going to get me? That's 1. Y squared over x squared, that is tangent. And r squared over x squared, oh yeah, that's secant squared. Now ours doesn't look like this, it looks like that. What would I need to do here? Subtract the tangent squared. So if I subtracted the tangent squared, I would get secant squared theta minus tangent squared theta. Oh yeah, that's that right there. And I don't care what this angle is. I just shouted out in my class earlier, what angle did you want? Somebody said 75. It doesn't matter what they picked. Because as long as I take secant squared to the minus tangent squared to the same number, what am I going to get every single time? I'm going to get 1 because that's what the Pythagorean identity tells me. It's just Pythagorean theorem in a fancy form. Questions with that? Yes, sir? It is not. It was minus 4. because I had a minus sign here from the cotangent that I brought in front. So it's -2 times 1 times 2. It was a plus sign when you wrote it down originally. Did you have a plus sign written down originally? Okay. It was minus. I screwed it up earlier, but I didn't screw it up this time. Question? Okay. It's challenging. I don't expect you to be excellent at that yet. I expect you to be okay.